I'm here to show you the work that I've done to functionalize the HAPI results. So the notebook I'm showing you here depends on a single script that builds upon the functionalities included in the Kamodo package as developed by CCMC and Ensemble. And I just threw that script in this Kamodo_CCMC directory to have it work here. That location will probably change. Okay, but let me demonstrate what's done. Okay, so here's the typical HAPI call. I chose a server and data set that depends on not just time, but also time and frequency. Okay, and here's a typical plot. Notice this plot doesn't show that much because the data actually needs a log scale to be properly interpreted. Here's a typical output from the HAPI plot call. But notice that I can functionalize the same outputs now with a single command to this function called Kamodofy HAPI. And then you get the LaTeX representation of the data variable as included in this variable here. And I can easily, with a single command, make a log scale plot of the same data. And you can see some of the structure here below. That's only visible with log scale. And you can also make a 1D plot and have the y-axis be log scale to imitate the log scale up here for the color. You can also easily have the x-axis be a log scale just by adding a similar command. Like so. And it's fast and it's interactive. That's one of the cool things about the Kamodo plotting capabilities. You can plot a lot of things with a single line of code and a couple options, and you get an interactive plot that can actually be saved as interactive through a couple different plotly calls. Different methods. Okay, but one of the powers of, or rather capabilities of Kamodo that really motivated this work was that it enables easy interpolation. And this is really important because the value that you want is actually typically at a time value that isn't in the data, so you have to interpolate between data points. And you can't do that unless you can't do that with a HAPI structure as is. So we're demonstrating how to do that with Kamodo on top of HAPI. Okay, so the first thing to do, we want to put this data on a regular frequency grid of the same range. So first we need to get that frequency grid, which can be done with a single line of code for the given variable. And here it is, it plots out here to the Python dictionary with the time, and these are UTC timestamps, and then the frequency grid. And here you can create a frequency grid that has regular spacing, unlike the one in the data, and then interpolate onto that frequency grid at a certain time with this call. Notice one line of code and you get what you need. Or you can do it for all times that are in the data without actually retrieving that with this line of code here. Or you can do it for a new grid of times, in this case, a finer grid of times. And the same frequency grid as before, again, with a single line of code once those grids are created. So this is a really powerful capability that motivated the work to basically functionalize the HAPI outputs to enable this interpolation capability and the interactive plotting with very simplistic syntax that currently works for a large sample of the variables already present on the HAPI servers. Okay, but we can go farther than that. The current interpolation that occurs behind the scenes uses SciPy's interp1D interpolator for one-dimensional data, such as time series data that is common with HAPI, and SciPy's regular grid interpolator for data that has higher dimensionality, such as the frequency spectrum functionalized earlier in the notebook. That's not always the best choice for a given data set. Sometimes users want to define their own custom interpolation method and have that be used as the interpolation method for that data set. So there's a really easy way to do this because of the capability developed now. So let's pull a happy data set that is a time variable, dependent only on time, such as the nlog kp output from ISWA. And here's a regular kp plots. I'm sorry, happy plots for those kp variables. The metadata, you can functionalize it just as before. You can plot all of the variables with a single call. You can interact with those plots, zoom in on pieces that you want. For one variable, you can zoom in on a different piece. Say, I want to see where it jumped. There you go. And you can take screenshots and so on and so forth. But let's look at the custom interpolation and how to include it. So I'm going to scroll past this and just explain it, but this is just the doc string for the Kamodofy _happy function that this depends on. So let's take, for example, a typical, just using the SciPy interp1d function, and instead of using linear interpolation, which is a default, I'm going to use, say, nearest neighbor interpolation, and create our custom interpolator like this, and it will get initialized with the correct coordinate data and variable data and Kamodofy HAPI, as long as it follows this syntax here. And this is all described in documentation, but let me not dive into those details here. So here, the same data that was functionalized a few blocks above is now functionalized with a custom interpolator with these lines of code. Other than creating the custom interpolator, the process can happen in one line of code, as demonstrated here. Well, this particular input assumes that the same interpolator will work for all of the variables in this data1 object and meta1 object returned by happy. But that's not always the case. Sometimes the variables have different dimensionality. Sometimes the user just wants a different interpolation method for different variables, even if they share dimensionalities and coordinate dependencies. So something more was needed. So the syntax change from this example to where more than one custom interpolator is included is very simple. So before we can get to that, let's create two custom interpolators. Let's just take the example from above and tweak a little bit. So say our first custom interpolator is a one-dimensional interpolator that I'm calling from SciPy. This is the same interp1d that was used earlier. And let's say the interpolation method here is cubic. And for the second one, it's S-linear. And you can look at SciPy's documentation for more information on those methods. But all we need to do to include these custom interpolation methods independently for the two variables is to simply put them in a list and where the order matches the order of the variables in the meta object returned by happy. And then there you go. Now you can't and you can do it with just one line of code. Now you can't tell per se here that the interpolation method here is different from this object or even different from the original object up here. You have to actually interpolate for a time value and see the difference in the results. So here's a third object before we do that, where the interpolators are actually included in the wrong order. So just a reverse order, and so that the cubic interpolator is assigned to the kp90 variable, and the S-linear is assigned to the kp18 variable. So different interpolation methods. So let's see what happens. So the first Kamodo object, that has linear interpolation for all of the variables, the two that we're including, the kp18 and 90. The custom has, what was it? The custom has the nearest neighbor interpolation for both of the variables. And custom 2 and custom 3 have cubic and S-linear in wonder assigned each to 18 and 90, and then 90 and 18. So we should have different interpolation results for a given sample date time, a given UTC timestamp for each of the two variables. And that is indeed what we see here. So we see linear interpolation, nearest neighbor interpolation, cubic here, S-linear here, S-linear here. And we see different results for all of these things. And you can just a simple closeout example. You can interpolate onto a grid of time values with a single command with the interpolator with the Kamodo object just after the timestamp array is created. So to summarize, it is now possible to Kamodofy or functionalize the HAPI output with a single line of code, as demonstrated at the top of this notebook and beginning of the video. And you can even include custom interpolators, either a blanket method for all of the variables or a custom interpolator defined differently for each variable to be functionalized. That's the capabilities now possible with this simple Kamodofy HAPI script. Thank you.